Hello everybody. Today we're actually going to do the proofs, the full-on proofs. We've been just kind of having enough information to prove two triangles congruent, so today we'll actually do it. Let's start by actually listing the 5 ways to prove triangles congruent. Remember that side-side-side congruence theorem, side angle side, angle side angle, angle angle side, and hypotenuse leg congruence theorem. We've gotten ourselves pretty familiar with them, but now we'll actually use them in a proof. But don't forget, sometimes they don't give us enough info to prove things right away, so we have to check for certain things. And those 4 things that we checked for was if there's a shared side, we can use the reflexive property. If there's any vertical angles, we can totally use the vertical angle theorem. Parallel lines is going to give us some angles congruent. And even if there was some isosceles triangles. So if you need to pause the video to write this down, you can do that. And let's just kind of dive in and start doing some proofs. We'll write down all of our given and then mark it. Segment MO is congruent to segment TO. Segment NO is congruent to segment PO. So I'll get that all written down. They want us to prove that these two triangles are congruent. Well, check out your picture. Do you have enough information to prove these two triangles congruent? No. So let's go through the checklist. Is there a shared side between these two triangles? No. Are there any parallel lines? No. Are there any vertical angles in this picture? Yes. So I will mark them, and then I will write them down. Make sure that you call the angle by 3 letters, because there's more than one angle that's got O for a vertex. So angle MON is congruent to angle TOP. And the reason why that is because of the vertical angle theorem. So we got that going. Now check out your picture. Do you have enough information to prove those two triangles congruent? Yes, by side angle side. So don't hurt yourself trying to figure out what to call the triangles and put them in corresponding order. They already got it up here. So just copy that down. Triangle MON is congruent to triangle TOP because of the side angle side congruence theorem. So booyah. We'll just prove those two triangles congruent. Let's keep rolling. Write your given down. Mark it. W is congruent to angle C. Segment WA is congruent to segment CA. Prove the two triangles congruent. Do you have enough information to prove the two triangles congruent right now? No. So go through the checklist. There are no shared sides. There are no parallel lines, but I do have vertical angles, and I will mark them with 2 arc marks because I already have 1 arc mark used up, and then I will write them down. Angle WAP is congruent to angle CAM by the vertical angle theorem. Then do I have enough information to prove those two triangles congruent? You bet. I can do angle side angle. So step 3, copy this down basically. Triangle PAW is congruent to triangle MAC by angle side angle congruence a theorem. Yeah. Given angle A is congruent to angle C, and angle ADB, that's this bad boy right here, double arc mark, is congruent to angle CBD. So that's what they give me. Do I have enough information? No. I got 2 angles. I need some sides, so I'll go through the checklist. Is there a shared side between the two triangles? Oh yeah, baby. This side right here, segment BD, is shared. So how do you write it down? Well, it's segment BD is congruent to itself. It's in both triangles, right? So segment BD is congruent to segment BD, and the reason that is happening is because of why we did that over and over and over. That's the reflexive property of congruence that says that anything's congruent to itself. So then I can do angle side. I just got to check that my angles go in the right order. It goes single arc mark, double arc mark side. The other one goes single arc mark, double arc mark side. So booyah. Triangle ABD is congruent to triangle CDB by angle side congruence theorem. Here, angle G is congruent to angle M. That's all they give me. right? They want me to prove those two triangles congruent, so I do not have enough information, so let's go through the checklist. One, is there a shared side between the two triangles? Yes. So let's write it down. Segment HE, or you can call it segment EH, it doesn't really matter, is congruent to segment HE. Reason, that's the reflexive property of congruence. So, boom. Now, do I have enough information to prove those two triangles congruent? No. So I keep going through the checklist. So shared sides used up. Next thing's parallel lines. Yes, I do have some parallel lines, so I'm going to get some angles out of that. Here's the parallel sides. When you put your arc mark, remember your arc mark has to touch one of the parallel sides, but then has to touch the same segment for a transversal. So if I do this, if I make this arc mark right here, touch the parallel side, it's going to touch segment EH for a transversal, and you got to use double arc marks. So then I got to go down and make an arc mark touch this other parallel side, but yet still touch the same segment EH for a transversal. So those two angles right there are congruent to each other. So step 3, you got to call this by 3 letters. Angle GHE is congruent to angle MEH. Reason, what did we have? Well, we had parallel lines. That's what they gave me. And that implies that these alternate interior angles are congruent to each other. And you know, they screwed up here. They should have also had that in the given information, which it is written on your worksheet. I believe segment GH is parallel to segment EM, and that should also be in the given right here. Segment GH is parallel to segment EM. I don't think my worksheet had that, but I don't know if I wrote that on your worksheet or not, but that should be in the given right there, because they gave it to us, right? So, rock and roll. We had parallel lines in our proof, so that implies that those alternate interior angles are congruent. But I still haven't proven what I want to prove. I want to prove those two triangles congruent. Well, now I check, do I have enough information? I got an angle, then another angle, then a side, angle, angle, side, and the arc marks go in the correct order. So, bingo, triangle EGH is congruent to triangle HME by angle, angle, side congruence theorem, my friends. And now we get to the dirty words. All of those were basic checklist proofs. Now it's time for the dirty words. Midpoint, bisector, circled, 3 dirty words. So remember how it works with a dirty word is skip over the dirty word and mark all non-dirty information first. So here's a dirty word. I'm going to skip over it. I'm going to mark this. Angle A is congruent to angle D. And angle 1 is congruent to angle 2. Now, instead of using arc marks to mark angle 1 congruent to angle 2, since angle 1 and angle 2 are a linear pair, they have to add together to equal 180 by the linear pair theorem. Since they're also congruent to each other, that means they got to be the same. So instead of using arc marks, I'm going to put right angle boxes because both of them have to be 90 degrees, right? Since they're a linear pair and they're congruent. So I'm going to put right angle boxes. So I've used this and I've used this. Now I've marked all non-dirty information. Now it's time to mark the midpoint, then immediately write down what it means. Remember, if they give you a midpoint, you have to use the definition of midpoint. So if C is the midpoint of segment AD, doesn't that mean that this should happen? Bada boom, right? So step 2, we know that segment AC got to be congruent to segment CD. That's what I just marked, and the reason why I know that is because C is the midpoint. That's what a midpoint means. So definition of midpoint. Boom. Now I have marked and used up all my given information. Now I look to see, do I have enough information to prove these two triangles congruent? Angle, side, angle looks good. So, and we got that on the other one. So step 3, triangle ABC is congruent to triangle DBC by angle, side, angle congruence theorem. So When I give you a dirty word, midpoint, bisector, or circle, mark all non-dirty information first, then go back, mark what the dirty word is, then immediately write down what you marked. So this symbol right here means parallel. It's just another way that they type it. So given that segment MN is parallel to segment PT, and segment NO is congruent to segment TO, so those get tick marks. They gave me that. Since they give me parallel lines, we're going to have to use them, right? And what we're going to get out of that is some angles. So do you notice they have numbers in them, 1, 2, 3, and 4? Since they usually number those, excuse me, since they number those, it's kind of a big clue that, hey, we probably better say something about those angles. So check this out. These are the parallel sides. Let's figure out which angles that we can get the same from those parallel sides. So if I put an arc mark in angle 1 right here, you notice how angle 1 touches this red parallel side and touches segment MP. Let me highlight that green. Segment MP. That's not green. Segment MP for a transversal. Well, the other arc mark has to touch the red parallel side and also touch the green segment for a transversal. So shouldn't angle 1 be congruent to angle 2? I know that. Angle 1 should be congruent to angle 2 because what did they give me that made that happen? They gave me parallel lines. And doesn't that imply that these angles are the same? Aren't they on alternate sides of this green segment in between those two parallel red segments? So they are alternate interior angles. Parallel lines implies that those alternate interior angles will be congruent. But you know, if I was still checking this out, like what about 3 and 4? I could have put an arc mark. If I would change colors, I could have put like an arc mark right here. This double red arc mark touches the red parallel line and it touches segment NT. So if I go back here and highlight this thing blue, isn't it true that I could have also said that these angles are the same because of those parallel lines, right? Because the double arc marks touch the red parallel lines and they touch the same blue segment for a transversal. So what I could do is I could kill two birds with one stone and say, hey, angle 1 is congruent to angle 2 because those parallel lines implied alternate interior angles congruent, but at the same time, angle 3 is congruent to angle 4 for the exact same reason. These parallel lines imply that those alternate interior angles are congruent. So I kind of did 2 for 1 special right there. Those parallel lines right there, they gave me 2 different sets of angles the same. And then on this information, now I want to see, do I have enough information to prove that I have these triangles congruent? Well, I could go angle, angle, side, and it went single arc mark, double arc mark, side. I could do that here, angle, angle, side, single arc mark, double arc mark, side. So step 3, holla, is triangle NMO is congruent to triangle TPO by angle, angle, side congruence theorem. And I guess one thing I kind of been skipping over is if you're going to prove 2 triangles congruent by angle, angle, side, you need to have 2 different sets of angles written down, right, because there's 2 A's, and you need to have 1 set of sides written in your proof right here. So I had that. If I go back to previous, I used angle, side, angle. I need 2 different sets of angles, 1 set of angle, 2 set of angles, and 1 set of sides right there. If you kind of go back here, angle, angle, side, you need 2 different sets of angles written down. So there's 1 set of angles, there's 2 sets of angles, and 1 set of sides. So it's just one of those deals where whatever you're using to prove, you got to have that information in your proof before you can actually say it. So now we get another dirty word, we get a bisect. Right? So let's mark all non-dirty information first. They say segment AB is congruent to segment CB. Got that. Then they say that segment BD bisects angle ABC. Okay? And it's been a while since we used a bisector, so let me think about this. If I bisect an apple, bisect means cut into 2 equal pieces. If I bisect an apple, what got cut into 2 equal pieces? Me or the apple? Well, the apple got cut into 2 equal pieces. Right? If segment BD bisects angle ABC, what got cut into 2 equal pieces? The segment or the angle? Well, the angle got cut into two equal pieces, right? And if you bisect an angle, you're going to get two little angles. Just like if I bisect an apple, I'm going to get two little apples out of that, right? You're not going to cut an apple in half and get two oranges out of it. If you're going to bisect an angle, you're going to get two little angles out of it, not two little segments. So if we want to mark this information, let me go green here. If this blue thing cut this red angle into two equal pieces, shouldn't this happen right here? This little angle has got to be the same as that little angle. The big red angle got cut into two equal pieces. All I have to do now is write down what I just marked. And isn't this angle ABD right here? This guy, angle ABD is congruent to angle CBD, because this thing bisected it, and that means that those have to be the same, so that's the definition of a bisector. Boom. This blue dude, this knife right here, cut that red angle into two equal pieces. Rock and roll. So I've used up everything they gave me. I marked that. They gave me a bisector. I marked it and wrote it down. Now I want to see, do I have enough information to prove these two triangles congruent? I got a side, I got an angle. In this triangle I don't have enough, so I got to go through the checklist. First thing on the checklist, is there a shared side between the two triangles? There sure is. So you'll double tick mark that and you'll write it down. Segment BD is congruent to segment BD. Reason, that's the reflexive property of congruence. And now, do I have enough information? Boom, side, angle, side, holla. So step 4, triangle ADB is congruent to triangle CDB by side, angle, side, congruence theorem. Just to check, to use side, angle, side, you need two different sets of sides and one set of angle, sides, and then there's the angles. So they don't have to be in any particular order. They just have to be in the proof. So